Okay, this is the second of two videos to kind of follow up with our explorations that we looked at today. And this is a follow-up of exploration 3, which is reflections in the x and y axis. And you looked at the graphs of them and kind of saw what happened with those things in exploration 3 and the communicating your answer. And so what we're going to do today is kind of formalize these things algebraically. Okay? All right, so here we go. So there's two types of reflections we're going to look at. First one's going to be reflection, what we say in the x-axis. You'll also hear me say reflection over the x-axis. Basically, just going to flip the graph over the x-axis and see what it looks like as far as an equation. Then we're going to do the same thing for the y. So how do we do that? It's very similar to the previous video where we have definitions of these things. And so basically what we say the graph. We start with reflection of the x-axis. The graph of y equals negative f of x is a reflection in the x-axis of y equals f of x. Okay? Basically, what happens is you take your equation, and once again, skip over that. I don't like that picture. It's not a good picture. Basically, what we need to do is kind of the same thing two different ways. So essentially what we're doing, we're multiplying our outputs. And remember when we talked about outputs, we're talking about our y's. Okay? You're going to multiply your outputs by -1. Or essentially, if you think about it in terms of an equation or a function, if you look up here, what do we do if our original function is f of x, our second function is negative f of x. So another way to say it is multiply the function by -1. Okay? So that's essentially what we're going to be doing here. Okay? If we're doing a reflection over the y-axis, it's a little bit different. So we say the graph of y equals f of negative x. So f of negative x is a reflection of our original, we say is that one right there, in the y-axis. Okay? And x-axis, y-axis. Okay. Once again, skip over that. I don't like those pictures. So essentially, what are we doing? We're here we're multiplying the outputs by -1. Here we're multiplying the inputs. Our inputs, which are x coordinates by -1. Negative, yes, spelled right, -1. But look at what happens if we go back up here. What do we have to do to the function? Substitute in negative x. T-U-T-E. And simplify. Alright, so let's go ahead and do that. So let me slide down here. So if we look at this example real quick, we've got y equals absolute value of x plus 3 plus 1. And if we look at part A, it says write a function g whose graph is a reflection in the x-axis. So we have to use this right here. Okay? So what we say is we say start with g of x equals negative f of x, because that's, if you want to call that an equation or a property, that's what we have to use. Okay? Alright, so, but what is f of x? F of x is this function right here. So we can say g of x is negative, and we got to put parentheses in here, whatever function f is, which is all of this, which is the absolute value of x plus 3, closing absolute value plus 1. Alright, our next step then is to take this negative and distribute it. Now it's interesting how you have to distribute it. Okay? This right here is one term. So I'm going to distribute it to not each of these individual pieces, but just out front here. Okay? And when we're talking about distributing the negative, ultimately what we're doing is we're multiplying by -1. So what happens here? I get g of x equals the negative absolute value of x plus 3 plus, minus 1. And we're done there. So this is, let me rewrite that. G of x equals negative absolute value of x plus 3 minus 1. Okay, so that's our new equation. So let's take a look at that on Desmos and make sure that it reflects it over the x-axis. Okay, so there's our original equation. F of x equals the absolute value of x plus 3 plus 1. Okay, and that's here in the red. Here is our new equation that we computed out. And notice that is a reflection in the x-axis over the x-axis. You can see they're mirror images of each other. So that's how you find the equation if you want to reflect it over the x-axis. You simply substitute in negative f of x, multiply the whole equation by -1. Similarly, part B, if we want to write a function h whose graph is a reflection of the y-axis, what do we have to do? We have to do h of x equals f of negative x. So basically I have to substitute in negative x in for x. So what's that look like? So I end up with h of x equals absolute value negative x plus 3. I replace x with negative x, and then I have to keep up my plus 1. Okay? Normally we would be done, but absolute values have a little bit a screwy thing here. Okay? There's no other simplification to do other than the fact that having a negative x inside the absolute value sign is considered to be bad math. So we have to do a little bit of work here. And essentially that work looks like this. H of x equals, what I have to do to this term right here, the x plus 3, is I have to factor out a -1. And so I've got absolute value, -1. Now what happens if I factor a -1 out of negative x? It becomes positive x. If you think of this plus 3 as positive for 3, what happens if I factor out a -1 from there? This becomes minus 3. And then this is still plus 1. Okay? An interesting thing about absolute values. Notice I got -1 times this piece right here, and it's all inside the absolute value. If you have two things that are multiplied by each other, that I do right there between the -1 and the x minus 3, if they are multiplied by each other, you can separate them into separate absolute values. So that becomes absolute value of -1 times the absolute value of x minus 3. And I still got this lovely plus 1 out there. Last step, when we have this -1 separated, what's the absolute value of -1, which is just 1. So this becomes just 1. This becomes the absolute value of x minus 3 plus 1. This is the equation we want right there. Okay. So the main thing here for this second part is we know we have to substitute in -x for x, which we did right there. Because that's inside an absolute value sign, that makes things kind of screwy, and so we have to do this process of getting the x to be positive. Okay. If you look at essentially what happened, notice I had -x plus 3, and it became positive x minus 3. So this kind of reverses the signs, and it should be an accurate answer. Okay, so let's take a look to make sure that graphically, to make sure that is a reflection. So here's our original function, and we have this one right here. That is a reflection over, whoops, that should be a plus 1, timeout. So let's go with plus 1. There we go. Alright. Reflection over the y-axis. So you see we just took this graph, floated it, flipped it over here. Alright. The third one that's on, and if you notice the next page, your third page says stretches and shrinks. We haven't talked about that at all. So that page right